Good morning, students. Today I shall discuss about elimination reaction. What is elimination reaction? An elimination reaction is an organic reaction where a molecule is eliminated from the substrate to form the product. There are two types of elimination reaction. One alpha elimination or 1,1 elimination, and the second one is beta elimination or 1,2 elimination. What is alpha elimination or 1,1 elimination? Atoms or groups are eliminated from the same carbon atom. For an example, suppose it is chloroform molecule CHCl3. So, if this chloroform molecule is treated with a base OH minus ion, suppose OH minus ion is a base. So, if base abstracts this hydrogen atom, then CCl3 minus will form. This is CCl3 minus, and if one Cl minus is removed from here, then dichlorocarbene will form. This is the dichlorocarbene. So this hydrogen as well as this chlorine, both atoms are eliminated from the same carbon atom. So this is called alpha elimination or 1,1 elimination. Second one is beta elimination or 1,2 elimination. Here atoms or groups are eliminated from the adjacent carbon atoms. Suppose this is an example of haloalkane, and if we treat this haloalkane with a base, the OH minus ion attack this proton and this bond will break, CC double bond will form, and this leaving group is removed from the substrate. So alkene will form. Now this hydrogen and this halogen both are eliminated from two different carbon atoms. So this is called beta elimination or 1,2 elimination. Suppose this is 1 number carbon, this is 2 number carbon. So X is removed from number 1 carbon and H is removed from 2 number carbon, so that it is known as 1,2 elimination. Next, depending upon different mechanism, beta eliminations are two types. Number 1, elimination unimolecular, and number 2, elimination bimolecular. Elimination unimolecular or E1 mechanism, elimination bimolecular or E2 mechanism. First one is elimination unimolecular or E1 mechanism. Suppose it is a alkyl halide. Now Br, that means bromine, is the leaving group here. So if bromine is removed here, then a carbocation will form. Now this, if the water molecule is treated with this carbocation, this water molecule accepts this proton. Here the water molecule is like a base, so it will absorb the proton and this CH bond will break and double bond will form. So this is a alkene. The product is alkene. This is two steps reaction. First step is slow step or rate determining step. Rate determining step means formation of carbocation. And the second step is the abstraction of proton by a base and formation of a alkene. This is our energy profile diagram of E1 elimination reaction or unimolecular reaction. So energy versus reaction coordinate. This is our alkyl halide, and first step is the formation of carbocation and the second step is formation of alkene. As the first step is our rate determining step, RDS, so in the rate equation only alkyl halide is present. There is no base is present in the rate equation. So the rate equation is rate equal to rate constant into concentration of alkyl halide. So that this type of elimination reaction is known as elimination unimolecular reaction. Next reaction is elimination bimolecular or E2. It is single step reaction where simultaneously three separate things happen. This is the alkyl halide. And first thing is the base abstraction of proton from the beta carbon atom. So if the leaving group attached with a carbon and this carbon is known as number 1 carbon or alpha carbon, the side carbon is known as beta carbon. So this is our beta carbon. Now this is our beta carbon. Now the base OET minus absorbs this beta proton. Okay, then CH bond will break and CC double bond will form and the leaving group is removed from the system. And this is the formation of alkene. The three things happen simultaneously. So number 1 is base abstraction. Base abstract the proton. Number 2 is forming of carbon-carbon double bond, and number 3 is halogen leaving as halide. These three phenomena happen simultaneously. So this reaction is E2 reaction or elimination bimolecular reaction. The stereochemistry of the reaction, here the proton and the leaving group may in same direction or may in opposite direction. So if it is same direction, then it is called syn elimination, and if it is opposite direction, then it is called anti-elimination. Next point is the role of the base in E2 and E1 elimination reaction. Suppose this is our alkyl halide and the base OH minus. This is the strong base. So this base will abstract this proton and this CH bond will break and CC double bond will form. This CC double bond will form and the leaving group will removed from the reaction reacting substrate. So the alkene is formed. This is E2 elimination. If the base is very weak, then the weak base, if we apply the weak base, then the first step is removing of leaving group. This is the removal of leaving group. So carbocation will form and then the weak base abstract this proton and the carbon-carbon double bond will form. Then the alkene is formed. So strong base always prefer E2 reaction, and if the base is weak, then E1 reaction happens. In case of E2 reaction, that means bimolecular elimination reaction, there are two important rules: Saint-Jeff rule and Hoffman rule. What is Saint-Jeff rule? According to Saint-Jeff, the more substituted alkene is major product. Suppose this is an alkyl halide. Now this carbon is the alpha carbon and there are 3 beta carbons. 1 beta, this is another beta, and this is another beta. So there are 3 beta carbons. So one product will be like this. If this beta hydrogen is abstracted by the base, then this product will form, and if this beta hydrogen is abstracted by the base, then this product will form. But according to Saint-Jeff rule, this alkene is more substituted, so this is the major product. Now according to Hoffman rule, if the base is sterically hindered, that means the size of the base is very large, then it is very difficult to approach the base towards the alkyl halide. So the less substituted product will be major product and more substituted product will be then minor product. There is another example. This is our carbocation and there are so many beta hydrogens. So there are 3 types of product may form. Now if the base is very much bulky, that means large size, then less substituted product will be major product and more substituted product will be minor product. according to Hoffman rule. Here some examples of elimination reaction. This is alkyl halide, base is sodium hydroxide, alkene will form. So this is also beta carbon, this is also a beta carbon. So if this beta proton is abstracted, then less substituted product will form, and if this beta proton is abstract, then more substituted product will form. So this is the major product. Similarly, if with the same alkyl halide, if we treat this alkyl halide with large base, then less substituted product is our major product. This is the less substituted product. Here are another examples. Here also the base is small base, so more substituted product is the major product, and here the base is large sized base, so less substituted product is the major product. Then the E1 versus S1 reaction. E1 means elimination unimolecular and SN1 means substitution nucleophilic unimolecular reaction. Now if we treat alkyl halide with base, E1 reaction will happen or SN1 reaction will happen. So first of all, a carbocation will generate, which is known as carbocation intermediate. Now, if after formation of carbocation, if the beta proton is abstracted by a base, if alkene is formed, then it is known as elimination product. And if water molecule attacks this positive center and OH, that means all group is present, alcohol is produced, then it is known as substitution reaction. That means bromine is substituted by OH group. Now, what are the differences between substitution and elimination reaction? In case of substitution reaction, OH minus is nucleophile. In case of elimination reaction, OH minus is a base. And second point is the organic product is alcohol in case of substitution. Here the alcohol is formed. This is substitution reaction. And in case of elimination reaction, alkene is the product. In case of substitution reaction, OH minus attacks the carbon that has halogen. This carbon that has halogen. But in case of elimination reaction, the base attacks the beta hydrogen. In case of substitution reaction, the solvent is water. This is the most important point. In case of elimination reaction, the solvent is ethanol. So these are the basic difference of substitution and elimination reaction. This is all about our elimination reaction. Thank you.